Okay, so let's see if that'll sit there and catch my voice, and I'm not worried about it missing my voice, but I'm so loud. And maybe it'll show good enough. We'll see. Okay, so that's what's going on there with that. I do have it on silent, so it shouldn't ring in the middle of anything. Okay, so did anybody else come in just now? Okay. Alrighty. Alright, so first thing we're going to do tonight is go over whatever questions y'all might have about stuff that's on the test, and then we'll be starting on the chapter 3 new material. So this was one, Matthew, you had sent me, and I didn't get a chance to answer it, so I figured I would start with it, even though the exact one is not off the test review, but definitely the type is. So this one was on your homework, and it gave us f of x equals 5x plus 6. Find f of negative 3. So f of negative 3. So with these, we said when we're composing that when we've got the particular number, we go back there and we want to evaluate it by plugging in this x number into the one that's right there hooked on it. So I'm coming over here to 5x plus 6, and I'm plugging in the negative 3. So 5x plus 6, 5, plug in the negative 3 plus 6. So that gets a negative 9. But remember, that is not the final answer because we haven't tackled this part of the problem, the name that's out front. Well, it just happens to be the same name, okay? But don't let that trip you up. It's just still saying we're going to take that answer, the negative 9, right? And now we're going to do f, so we're still just using the same f rule, but we're plugging in the negative 9 now. So, for my final answer, f is still 5x plus 6. So now I'm plugging in that previous answer to get our final answer. Okay? So don't let it trip you up if it's got, the same name duplicated. You do it the exact same way. It's just that you're only using the f of x or, whichever one it is. Okay? All right. So what other questions have y'all got? So I told you we're not reviewing. I said I will clear up any questions that you have. So if you don't have any, that means we're going straight to chapter 3. Who's got any questions? Have y'all looked at the review and you just got it that good? Oh no, y'all haven't looked at that review, have you? Shame on y'all. Shame on. Oh, have y'all finished your homework? Yeah. Okay, well that's good. That's a little bit of saving grace for you, a little bit. All right. So, anything from the homework that you did, even though you hadn't looked at the test review yet, any of those ideas that you know you need to ask about that you just still don't have down, anything standing out in your memory? Y'all don't forget that this is a short summer class. Yes, ma'am, Miss Alicia.
We had the two equations on each side. We had through the graph. It was 5x minus 1 plus 6x equals 4x plus 5.
Okay.
And when I did it by hand, I got the 6 over 13. But when I did it on the calculator, I got 6 over 11.
Okay. All right, so let's do that one. And all right, And so I'm gonna let you call it back out a little slower since I'm clicking with the mouse. Okay, so say the one side.
5x minus 1 plus 6x.
Minus 1 plus 6x.
On the other side, I got 4x plus 5 minus 6x.
Okay, and so I'm going over this, but do remember as far as on the test, you do need to be knowing how to do it. That's why I'm going over it. But there won't be any on the test doing the calculator steps and stuff. But we've got to be
Yeah,
knowing how, you know, for
that's fine.
upgoing.
So
Yeah,
none of the calculator stuff's gonna be on the test.
right,
Okay.
You said no calculus?
right. I'm cutting y'all a little break on the first test. You will have it on all the other tests, but I'm giving you a little bit extra time for learning it. All right, so we did our Zoom 6. And we're going to be looking to pinpoint where they're intersecting. Okay, and so we see that nice and clean on the Zoom 6 shot of it, so we don't need to worry about it just in the window. Second trace, 5 for intersect. Slide towards where they're intersecting, enter, enter, enter. Okay, and we get this decimal. Now, look down there. Let me pull that. Okay, let's see. All right, so now look at the X that's down there very carefully, and you'll see right there that it starts repeating. Like the whole group of numbers, not just 2 of the numbers. Okay? So when you go, see that whole 4, 6, 1, 5, 3, 8 is what's repeating. Like that. So grab that calculator. And out on your home screen, you know, do your second quit. And then type in about 3 of those groups. 4.461538. 461538. 461538. And then do your math enter, enter. And it should give you the correct fraction. Okay? Now there were a couple, depending on how the homework regenerated like a problem for you, depending on numbers on a couple of those that were in that section, where you could not tell what was starting to repeat. Like it wasn't as clear as this one with a 4, 6 and a 4, 6. And so on those, the ones who texted me or emailed me, I told them that out on the home screen, you could type the X and press enter to see a few more digits, and then you might be able to see where it's repeating. But on one that I did, I think yesterday, for somebody, let me see if I've got it. Well, I won't, that'll take too much time. But anyways, so let's say you do X enter out on the home screen, and you still can't tell, you know, how it's repeating, but the directions tell you, you know, to put it as a whole number, well, an integer or a fraction. So you know that it's got to be one that can be written as a fraction, or they wouldn't be telling you to do that. So in that case, 99.9% of the time, after you're sitting there and you've got it stretched out, if then you just do the math enter, enter, usually it will, you know, give you that correct fraction then. Because again, by pulling it up first, it's looking at the whole long number and what keeps on going, you know, out beyond it. And so it gets that that's what it's changing into a fraction. Okay? All right, what other
Can you
questions?
go over one of the inverse functions?
Okay. We sure can. And I'm guessing that you're not talking about the basic idea right there. You're talking about where we actually have to find it. Okay. And so, let's see. Let me get one that's a little bit different. Okay. That's not too easy. We're real straightforward. So, okay, on this one, that was all, well, it'll still be good for my purposes. Okay, so this one, when you graph it, I started to say it is 1-to-1, but yeah, I think it should still be. Y'all graph that right quick and see if it's 1-to-1. What are you checking for against the graph to see if it's 1-to-1? Horizontal line test, good. Okay, and so does it pass? Okay, okay. All right, so it is. So then, if we want to find the inverse, okay, we would first replace the left side, the function notation, with the y equal. So y equals 3x cubed plus 5. So we put the y back into the problem so that we can do what next? Switch the variables. So x goes here, 3y goes there, and everything else around it stays the same. And now you use however many steps it takes to solve for that new y, and that will be your inverse. So on this one, okay, we're trying to get the y by itself. Okay, so what's the first thing that I could move away from it over there on that right side? The 5, and I would subtract that, that's right. So x minus 5 equals 3y cubed. Now what would I get rid of on the right side? The big 3 first. Right, divide both sides by that 3. Now, see when it's just the y to the third, now we get rid of the cube power, the third power. And so, cube root. And so, that big cube root is our y, which is our inverse for what we started with. Okay, I think this one is another one that is 1-to-1, and it's a little bit different. you know, as far as finding that inverse. So y'all check me, graph that. How are you gonna type it in to graph it correctly? Parentheses. I'm thinking it's like the curve up here and then the curve down bottom, so they don't line up horizontally, right? Okay, so it is 1 to 1. All right, so y equals swap now. All right, so now solve for that y. Well, that y is sitting down in the bottom of the fraction with a +8. What do we need to do? Very good, yes. The y plus 8, that denominator gets multiplied on each side. So there's the x, here's the 5/. Okay, that way over here on the right side, they're completely gone. And it's up out of the denominator now over here on the left side. Okay, what do you think we should do at this point? Trying to get y by itself. There's 2 different ways we could go that are correct, actually. There's 2 correct ways that you could go from this point. All right, we could distribute. Okay, that would give me yx plus 8x equal 5. And remember, we're just trying to get this y by itself. So if we distributed, what would we do now? Very good. And then last thing, for this y to be by itself. Right. And so the inverse would be the 5 minus 8x all over the x. Okay? All right, what other questions?
What other than was it? You said
Yeah. Okay, the other way would have been right here when we just had, well, had that little, that whole thing like that, all of that. So, okay, so we had this part equals the 5, and we'd canceled out the y plus 8. Okay, so we'd canceled. All right, so what we could have done then, right here, instead of distributing, you know, we're wanting that y by itself, and so we could have said, well, let's divide each side by that x right now. And so over here by the x. Those would have canceled, and now it would have left the y plus 8 equals the 5 over x. And then we would just subtract that, right, to get the y by itself. And so that would also be our inverse function. Now, they don't look the same, but they mean the same. Because like on this first one that we were looking at, when you've got a sum or a difference up top, but just one single thing down bottom, then those can be split apart and each piece of the top goes over whatever's in the bottom. So see, that's saying that this would be a 5 over x minus an 8x over x. Well, 5 over x doesn't simplify, but 8x over x simplifies to what? Plain old 8. And so that's what we had over here. So they are equivalent, they just look like they're, you know, totally different things. And it's just about which step clicks at this point up here along the way.
That's why I wanted to see the other way, because
Mhm.
I will try to cancel out the x's. and I-
Okay. Okay. Yeah, you cancel in one, but you keep it under, you know, the other one, yeah. Okay. What else? Is this Bessie? Okay, we're just going over, asking questions that would be on the test
Okay.
right now.
This is a question that was actually in my notes.
Okay.
Can you go over, the square would be like the first example that you gave us, it's like, h of x is equal to x plus 2, and g of x is equal to x squared plus 3.
Okay, and what is it that we want to find? What is it asking us to do? Just like h of g of x, or g of h of x, or a number?
It's f bracket g, it's x, and then another bracket, like I can show you.
Okay, so we needed an f of x then, also, in the given.
It's like,
Maybe I listened wrong.
I can't explain it.
Okay, g of h of x up there, okay. G of h of x is what we're being asked to find. Okay, so remember on the first one that we did tonight, we had a number back there, so when I wrote it like this and kind of stretched it apart, this was actually something where I could plug in a number. On the one now that we're looking at, that's not the case. We just got h of x, the rule h of x. So that means we're wanting to find, this was where we would just drop down beneath it and write that rule. And keep the front name. So G comes down, and now instead of it saying G of h of x, it's going to say G of x, whoops, my bad, x plus 2. Because that's the h of x rule. Okay? Now, what does that want us to do? Well, that wants us to take whatever I see in here, whether it's a single number or an algebraic expression like that, and put it into g of x, which is x squared plus 3, right? So right there, I'm going to put x plus 2. And the rest of it stays exactly the same. So it's still going to say squared and the plus 3c. So that's the composing. From here down, it's remembering your algebra 1 and 2 correctly, you know, and doing those steps. So we remember that when we see the squared on something like that, that we've got to figure it out by multiplying it by itself. 2x and 2x, 4x in the middle. And then combine like terms. So x squared plus 4x plus 7. Okay? Okay, what else? right. Let's see. Okay. All right. So, how can the graph of h of x equals 1 over x minus 3 be obtained from the graph of f of x equals 1 over x? So 1 over x is our parent graph, the basic graph. We're going to look at the number. Is the number, which is this minus 3, inside or outside? Is it inside the parent function with the x, or is it outside of the whole parent function? Outside. So, outside first means which pair of directions, up, down, or left, right? For outside. Up, down. Okay, and then, is it the same as what we would think from the sign, or is it the opposite of those two from what we would think on the sign? Same. So, what does that mean from the up, down, if it's a minus 3 then? Down 3 units, that's right. Okay. All right, so then if we've got this one, 1 over x plus 5 plus 6. Okay? So, from what we just said, the plus 6 is the outside number. We said that's about up or down, and the same as what we would think from the sign. So that means the 5 is inside 1 over x with the x, see? It's down there with the x. It is the left or right, but it is the opposite of what we would think from the sign. So, what two things is it going to be doing? Are those two numbers going to be doing? The 5 is left, and the 6 is what? Okay, yeah. So, which one says that? B? Left 5, up 6, yes. So, choice B there.
How did we redetermine left five?
The 5 is inside, it's written where the variable is written. And so that tells you that it's going left or right. And it's the opposite from what the sign would make you think about those. So, if, yeah, plus would normally be right, negative would make you think left, but it's the opposite. Okay? So this last one, I just gave you one of these, but it's just as easy. But it's asking you to come up with the equation. The basic equation, the parent equation, is just square root of x. And it says it wants it to go 10 units to the left and then 8 up. Well, we know left and right comes from the inside, the number being inside with the x, where you see your x. The up or down is from outside. And we know the left, right, the inside is the opposite of what we would think for the sine, and the up or down is the same as what we would think for the sine. So, take it piece by piece without looking over here at the answers. Let's think it through first. Having the answers there makes it too easy for y'all. So we got y equals square root of x. So inside we're talking about being here. Outside we're talking about being back here. So what is somebody thinking?
Maybe square root of x plus 10,
Perfect, yep.
and then plus 8 on the outside.
Yes. Very good. So this little group of information sent that part there. And this sent that one. Very good. Okay. I know I said I wasn't gonna do this, but I'm gonna do a little bit of it. All right, I'm gonna let you kind of glance and see. Hopefully, more of it comes back than not after I quit playing with this cursor over here and mouse. It will agree with me. All right. All right, so with these, I don't know what. I mean, I know what, but I don't know that I'm doing the what to make it do that, but obviously I am. All right, I know y'all can do those top few right there. All right, I know most of these right here you can do, but let's grab one of these kind of a little bit trickier. Let's do the C and the B. All right, so the C one here and the B one here. A little bit trickier. So on 24C, f of a minus 1. What are we doing? That's right. Right there and right there, putting the whole a minus 1 in a set of parentheses and then seeing what we can do with it. So a minus 1 squared minus another a minus 1 and then the minus 3. And then I've already reminded y'all tonight, so what are you going to be doing with the a minus 1 squared? Okay, times itself. So minus 1a is a minus 2a right there. And then negative 1 times negative 1. Okay. All right, what will we be doing behind it where it's got the minus a minus 1? Good. So what's that going to give me to write down? Okay. And then we still just got the minus 3 back there. And so at that point, just combining any like terms. A squared minus 3a minus 1. Okay. Now, on 25 down here, okay, we're plugging in where I see the x's, the whole x plus 1. right? Okay, so that means I've got the little fraction. So up top, I'm plugging x plus 1, and then it's got the minus 7. Down bottom, I'm plugging the x plus 1, and then it's got the plus 5. What do you want to do at that point? What kind of old clean algebra 1 cleaning up, simplifying?
Couldn't you cancel out
Yes, on the X plus one.
Oh, see, I just knew. I saw the fraction. I'm like, well, let me do both of them because they're going to want to cancel that stuff out. No, you can't cancel unless something is being multiplied with something else. No cancel here. See, if it were the x plus 1 times the 7 over an x plus 1 times whatever, the 5, then, because those are common factors and they can cancel out. But when it's adding and subtracting, they're not factors and you cannot cancel terms. So, we simply remove the parentheses because there's nothing out in front like being distributed. And now, seeing it written like that, what are you thinking?
X minus 6 over X minus 6.
Right, combine those like terms right there and right there. And again, you cannot do any canceling down there either, because there's not anything multiplying up here or multiplying down bottom.
The fraction.
Okay, like right here. Okay. Alrighty.
Wait, was that the final answer?
All right, so on D, let's see. All right, so it's f of -1/2. Okay, so both the same x place, we're plugging in the -1/2. So, let's see what happens. All right, -1/2 minus 7 over -1/2 plus 5. Now, grab your calculators and do the two little arithmetic problems and math enter, you know, at the end of it as you punch that in and your math enter. And I think you get those two fractions, -15/2 and then 9/2. Did I do that right in my head? Okay.
Hypothetically speaking, this was like a homework question.
Uh-huh.
We put it in like that with like fraction over a fraction.
Okay, we're not finished. Yeah, not even up here. Not even in the classroom, we're not finished. Because you're right, if you tried it like that, it would say, your answer is equivalent to a correct answer, but it's not simplified or something like that. It doesn't tell you straight out you're wrong, but it won't accept it, yeah. So here's what we do. Once we get it to one single fraction over one single fraction, not like the adding and subtracting that was up above it, then we can say, well, what is that really saying? Well, it's really saying that top fraction is being divided by the bottom fraction. And what, if we write that out sideways, way back in elementary school when you learned all about dividing fractions, what is the basic rule of dividing fractions?
You flip them around and then multiply.
Okay, flip the second one, keep the front one the same, times, and we flip this though, right? The reciprocal is that word, in case I ever use that word. Oh, and now I see that I can cancel something. I can cancel my 2's out right there because it's multiplication and that's a factor. And then what can I cancel out of the 9 and the 15? A 3. So that would leave me a 3 here and a -5. And then we would go straight across and straight across. So -5 over 3 would be our final simplified answer. And even though I actually did that by hand, like right there, but really from even right here, you could still have gone to your calculator right there. You would just have to use parentheses very carefully. You would put parentheses, the -15 halves, parentheses, and then your big like divided by, and then parentheses, the 9 halves, and the parentheses to get it correct, and your math enter. So you would just have to do those parentheses if you know, to grab your calculator right there. And see, some of y'all, the ones who have gotten used to doing the little green, the shift the alpha y equals, you could have done it right here from the very beginning. If you've got that sideways bar, you could have just done the bar -7, the fraction minus the 7, and the big bar, and then the fraction plus the 5. If you've been sort of training your mind for the fractions to do that green y equal enter, so you could have actually gone from the very beginning. Okay. All right. On one like 26, what did we learn about to find the function values from the graph? It's kind of blurry when I pull it up, but I think on y'all's sheets you can read a little bit better. So this is just, we're finding f of 2, f of -4, f of 0. This is one of those gimme problems. Should be on the test. So what are your answers? Don't tell me like the number, but what idea is the answer when we're looking for the function value from the graph? Right, the y number that goes with each of these x numbers. So f of 2 would be what? -1, that's right there. F of -4 would be -3 from over here, from that point, and f of 0, they don't have it highlighted, you got to figure it out. Yeah, -1, it would be that point right there, they just don't have it named for you, right? But it went down 1 to get there. Okay. This room, I'm not used to being in this room until this summer. I'm always next door. That's what I'm going to blame it on. All right, determine whether that graph is of a function. So what are we using on 27, 28 to decide if it's a function? Vertical. Horizontals for what? 1 to 1. So vertical line test. So 27, yes or no? No, right? Okay. 28, yes. All right. Do what? Vertical line test?
I got it.
I think my 37 and 38 must have gotten off from where they were supposed to be because they're obviously functions because it says f of x equals and h of x equals. So that must have been supposed to have been down here. Those two. So if you've got those printed out, oh, don't let me write there. But make a little note right here beside your number 34. Or right here above it and just put find domain, because that's what it was for these right in here, was to find the domain. I just didn't catch that before I saved it and stuff. Okay. So those are more vertical line tests. Okay. When we do have something and we want to find the domain of the function, and we don't have the picture, we don't have ordered pairs, we don't have arrows, we just got the rule in front of us. Okay? So, there was like a general little rule when we were going over that I told you to remember that would help you when you just got it there. Because when we were talking about this, we were like, well, most of the time, your domain goes all the way across. It's negative infinity to infinity. But the domain, remember, is the set of all the numbers you can plug in and work the problem to get an answer. And there were two kinds of problems where there's some numbers that when you try to plug them in, you won't be able to work the problem, and they would be undefined. So who remembers what were the two kinds? And if it's anything other than those two, you know that the domain is all real numbers, negative and positive infinity. But what were the two trouble functions? Halfway there. Fractions. No, not about absolute value.
It's negative, it's square root.
And square roots. Right. And so what is the trouble about fractions? What will make that make a fraction undefined?
The zeros on the bottom.
Okay? And what's the deal about square roots?
Negatives.
Right. Other than that, if it's not a fraction with your x down in the bottom, and it's not a square root with the x underneath, it's going to be all real numbers. Okay? So, what's your domain on number 31? All real numbers. That's right. Jump down to 37. So, what's the domain on 37? All real numbers. See, there shouldn't even be any thought. When you see there's not a fraction, there's not a square root. What's the domain for 38? Okay, but now the remaining three are fractions, right? So you have to kind of slam on brakes and start thinking. And so we said up here, we have to think about not letting the denominator be 0. Right? So, what can I not let the x be on number 32? 0. Right? Because that's all, it's just plain x sitting down there. So it cannot be 0. So how will I write the domain with interval notation? The domain saying it can be any x except 0. Y'all, we've been doing interval notation since June 2nd or 3rd or 4th, whichever that first Tuesday was. Come on now.
Negative infinity to negative 1.
No.
Negative infinity,
To
negative infinity
0 with the
zero.
open circle.
Okay. And in the interval notation, it would mean the open circle, but we don't have the open circle.
It would be a bracket.
No, it'd be a
No,
parenthesis.
parentheses.
All right. And is that it?
No, it would.
Okay, there's some more, right? It jumps over the bad number 0. And what's the rest of it?
Parenthesis 0.
Infinity. All right. What about on 33? how are we gonna figure out what, you know, what we need to leave out there? What's gonna make that 0? X squared minus 6x plus 5. How are we gonna tell what makes that 0? What?
Simplify.
Well, what do you mean by simplify? Okay, how though? So how would we solve for x? Yeah, we need to solve for x, that's right. How would we do that? Okay, we said it equal to 0, so, but then what would we do? Factoring, there we go. We would factor and then see what each one of those factors produce. All right, how's the factoring gonna go? Is factors missing anything?
Oh,
It's like, dumb Miss Haley, you know there's an X in there. Alrighty, x minus 5, x minus 1, which means the x's can't be what? Positive 5 and positive 1, right? So what is that interval notation?
Parentheses, negative, infinity.
Okay, give me 1 second, I'm gonna drag this down a little bit more. Okay, so negative infinity to 1, because what is smaller, with a parentheses first, then the union.
1 and 5.
In between the 1 and the 5, very good.
And then 5
And then we jump over the 5 and it goes the rest of the way out, yes.
I'm a little confused. Does parentheses mean closed circle or open?
Open. Right, it would be an open circle over on the number lines, yes. Coming real close to whatever number it's hooked on, but not including. Okay. All right, and then 34 is another fraction. Okay. You're not going to freak because all of a sudden there's absolute value bars in there. You're still going to go, well, I just can't let that be 0. So for it to be 0, that 16 minus x squared can't equal 0, right? I'm not doing anything with the bars, the absolute value bars. That has nothing to do with it becoming a 0 or not. It's what's inside of there that can't turn into a big old 0. So 16 minus x squared, and you can be writing equal or not equal to 0. I'm just going to put the not equal because that's really what we don't want it to be. We just said we would factor those kind. How is that one going to factor?
4 times 4.
Say it again.
4 and 4.
Okay.
That'd be x plus 4 and x plus 4.
Okay. It would actually have to be the 4's up front. It has to go the way it's written.
Okay.
So the answers, the solutions will still turn out to be the same, but for the factors, the 16 square roots have to be in the front and the x squared stuff has to be in the back. All right, and then what's the deal about the signs here? Okay, 1 plus 1 minus. Difference of 2 squares rule. All right, and then we split them up. So here, whoops, my bad again. X cannot equal what from the first one? -4, and from over here, okay, and so my interval notation.
-4 plus the parentheses. I gotta finish it out.
Yeah, girl. You rolling, Dashay?
Okay, another parentheses, and then you do 4, no, -4, and then another 4.
Okay, in between those two, that's right.
Yeah, then you do another, well, union,
Okay,
and then you do parentheses, 14, and
Very good.
close parentheses.
very good. Okay. All right, let's see. We won't work it, but what would you do to work the question, part A right there on the word problem 49? What is it wanting us to do?
Plug those numbers in.
Plugging those numbers in, right? That's right. So you could use your table on the calculator, but it's not where you have to, you know, so. Since I said you wouldn't have to do any of those. All right, and that's just another little domain focusing only on the bottom, right? Don't glance at those answers and start thinking, oh, it must be the top also, because most of those have a -3 in it. Nope, doesn't have anything to do with the top part being 0, right? So don't get tricked by little things like that. Same, 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 same. All right, we hadn't done one with the domain and range from the picture. Okay, so we've got this little squiggle. We want domain and range. Who remembers how we tell the domain from a graph?
The domain would be looking at left and right.
Good. And so as we're looking left and right, which numbers are we using to name it in interval notation?
Yeah, exactly.
Right. So from what left x to what right x. Alrighty, so what would the answer to that question be on this particular problem?
So it'd be -4 and 3.
Okay. Right, that's the furthest left x and the furthest right x. And so what symbols are around those two?
-4 will be parentheses.
Including it, the solid circle. Yeah. And then the 3 parentheses. All right, now the range, how are we naming, what are we looking at and how are we naming the range? Good. From the bottom Y, he said, to the top Y. So, here's my bottom point. What is its Y number? -4. All right, and yes, there is my top point, and the 5. All right, so how would we write the range then?
Bracket of -4,
Okay,
then 5 with parentheses.
yes. So even though they both have -4s in the beginning, for the beginning number, It's for two completely different reasons. The first one right here, domain, was because of the -4 up here on the x-axis. Over here with the range, it was because of the -4 on the y-axis for being the lowest. Okay. Increasing, decreasing, constant.
Do number 4. I think it was one like that on the homework. I almost put the computer on the floor when I tried.
Oh, goodness. Math always, it just seems to bring out the best in students when they're at home doing their homework all by themselves. All righty. So, increasing, decreasing, and constant. Okay. Left to right, going up, going down, staying the same. So, this first section of all one direction is going what direction? Which type is that? Okay. Now, the two rules to name it, you're still using X numbers to name them, but it's automatic parentheses for the symbols.
So it doesn't matter if it's closed or open? So-
Right. For increase and
See,
decrease and
that's what
constant.
was getting.
Right.
And why I was confused on that, because
Yes. So you just got to remember for the directions, that's where it's the automatic. Yeah. So what is that one going to be for this first decreasing? Right. These are the X numbers. All right. Then this little section is doing what? Okay. From where to where? Right. Again, the X's. Then it jumps all of that. Jumps over the river of no points. And the next direction we see is right there doing what? Okay, increasing. From where to where, automatic parentheses. Okay. X to X. And then the last section, decreasing from where to where? 4, for this 4 to 5. Yes, not 4 for the height of it. Right? You're still naming it from this X to the X of that one, which is the 5 right there next to it. Now, on your homework, it had something very close to this and asked you about domain and range. And what was so not understood about it was where I drew the river there, where there's no points in there. See, so for that whole group right there, those X's aren't being used for any points. So my domain can't go all the way from this left all the way to that right because it's got that gap in there where there's not any. So instead you have to say, okay, so what are all of these X's? And then what are all of these X's? Okay, so from left to right, it starts right here with that -5 with a solid dot, so it's going back to the bracket, Jonathan. And even though it's split apart, it's still using, like right down here, it's got that X number, but it picks right up here, super, super close, to it. So it's still using all these different little numbers that are in here. And so it goes all the way over to that -1, which has a solid dot. Then its union, it jumps over where there's not any, and now it starts right here, an X of 2 with a solid dot, so a bracket, and goes to where? The 5, the X number. The X number of this last point. Okay. All right, so there's a lot more stuff there for y'all to study and practice. Okay, so that's going to be it for practicing in here, not it for class tonight. Okay, so take a little break. There are 30 questions. A lot of them, though, are just like yes, no, or this X, this X, this X for domain, and that Y, that Y. I mean, little half-second problems. So, all right, let's see.
So, on the 16th, I thought there was only 2 spaces. And I looked that night, it was like, oh, it's not this.
Surprise! There's a bunch more. They're still open, though, right? You're still able to click on them.
And I can finish.
Okay, yeah.
I'm gonna send you over my schedule, either tonight or in the morning, just
Okay.
to see if you can do anything about it. If not, then I expect it, but fingers crossed.
All righty.
So Ms. Haley, you said that the 500 building, they're gonna be open on Tuesdays, Thursdays.
Well, supposedly they're open all, like Monday through Thursday till 6 o'clock.
Okay.
Supposedly. I don't have a lot of faith. I do not say that out loud. Some of y'all might work over there, work studies, or work, or, and here I am, bad mouthing. Yes, they are supposed to, they told me they're open till 6 o'clock for students, for that little office, yeah. Wait. Oh, I'm on Thursday. Lord have mercy. I was like, I thought I marked this person and marked that person. And then I'm on Thursdays. So let's see how this is doing.